Mr. Minnick helping my students answer tricky multiple choice questions that could show up on the AP exam. Question number 1. First of all, realize that there is no such thing as a read double method built into Java. In fact, there's no I/O class. There's a string class and there's a math class, but there's no I/O class. So the AP exercise here is just telling you in this comment to assume that this line of code reads user input. In other words, it allows the user to input a decimal number, a double, and whatever decimal number, say 5.4, that's inputted, let's just pretend it's 5.4, that decimal number is then being stored into the variable base. And similarly, some other decimal number, say, I don't know, 3.1, is plugged into the variable exp. Okay, so we have to find the code that matches this missing chunk here, so that when we eventually system out print, the variable power prints out that it correctly expresses something raised to an exponent. Well, the first Roman numeral option here is just totally wrong. There's no such thing as the ability to declare a math object reference. You'll never see math and then space like num, equals like 3. You'll never see that. It's illegal. You can have the line of code string name equals Bill. That's legal. You probably saw it in my lecture notes and demo programs at this point in the school year, but you've never seen anything like that in my lecture notes, and I'm just telling you it's illegal. So that second line of code is just a stupidness. That's out, so that means that rules out answer D and E and A. So at this point, if you're under time pressure, just guess between B and C. Because on the AP exam, currently, they do not take off points for wrong answers. They just don't give you any positive points for getting it right if you miss it. So at least guess between B and C at this point. Okay, but we have higher expectations here. Let's figure out which of these is the right way of solving this problem. Well, it looks like it boils down to whether power, the variable power, needs to be a decimal number or a whole number. That's what it comes down to. Well, it's as simple as this. What data type does the PAL method found in the math class, what data type gets returned and kicked back or sent and assigned into the variable power? Is it a decimal number, such as like say 38.6, or is it guaranteed to be a whole number, like 38? I know in your simple life of always having examples like this in math class, you always get whole numbers when you have whole number bases and exponents. But it is possible, probably in like a calculus class, to have something like this. It is possible to have something like 3.4 raised to the 2.8 power. That is possible in the world of math. Now, I can't do that in my head. I could do it on a calculator, and I don't even know how to do that on scratch paper. I just would use a calculator. Or I would open up Java and use the math.pal method, because it would work. The answer here is Roman numeral 2. The answer is B. This does come out to some number, like, I don't know, 12.623 or something. It does work. It does not always come out to a whole number like 12. No, this is a messy answer. Now, how would you also get to the bottom of that if you did not have that wisdom in the world of math to know that you can have decimal numbers raised to decimal exponents? Well, I'll show you. You could flip over to the cheat sheet, as I call it. Simply go to my Java homepage, go over there to the right column that says Resources, and somewhere down there under AP Exam Info, I have a link to Quick Reference Cheat Sheet. Click on that, and please make note that during the AP exam, you're allowed to use this piece of paper. They give you this during the multiple choice section and the writing out code free response section. And on this cheat sheet, as I call it, they call it the quick reference. There's a little section here for math, the math class, and right here for the POW method, you can see that this use of the word double right here in front of POW, that means that the POW method returns and kicks out decimal numbers. And we also see here that base and exponent, the two parameters in the parentheses, they go in as decimal numbers. So even if you have the number like 2 raised to the third power, it would be 2.0 raised to the 3.0, which is still 8.0, but just saying, it could be messy decimal numbers. So because that is not int, I know that the answer to this question right here is B, Roman numeral 2, and not Roman numeral 3, where it kicks back an int. The other way to know what that math.pow returns a double and not an int would be to actually go visit the API, the Java API, which you cannot use during the AP exam, but it would be handy to do homework such as this. If you Google the Java API, or just click on my link again here on my homepage, Java API, and then if you scroll down the left edge here, this is the API from Oracle.com, the company that's in charge of Java. They provide this help manual known as an application programmer's interface, and all the classes, all the tools or types of objects that are that's built into Java, including string and including math, is in here. Okay, I got to go to the M's for math. And let's go to the math class and find this POW method to see what data type it returns. Okay, here's the math class. And now in the middle window here, I scroll down to the POW method. There it is. And I can see by the use of the word double right here that it returns a decimal number rather than a whole number. Okay, moving on to question number 2 in this tricky worksheet. If you have 4 int variables, a, b, c, and m, which of the following is the best answer? Wow, they always make you doubt yourselves on these. Well, the best answer would be m. In fact, you're guaranteed that if a, b, and c are 3 different whole numbers, and I don't know if they have to be positive or negative, so I'm just going to throw in like easy numbers like 1, 2, and 3. If you plug in 1 and 3 here for a and c, and 2 and 3, you're guaranteed that when you call the min method, 1 is a result of that, because it's the smallest, and 2 is a result of that. But now you're in this outer set of parentheses with the min method of 1, 2, and 1's the min of that. Well, 1, m, the variable m ends up being 1. 1 ends up being assigned into the variable m. Okay, let's scramble them and put a 2 there, and a 1 there, and a 3 there. Well, trust me, if I plug in these 3 values for a, b, and c respectively, 1 will come out. That's the smallest number. And probably if you even stick in negative numbers like -2, -3, and -1. Now in this case, -3 would be the smallest number, because -3 is smaller than -1. Think about it. Well, you plug in as many numbers as you want, combinations for a, b, and c, and it will come out to this always working. Some people just have good logic and good intuition to not have to test a bunch of test cases. Other people, they spend all day plugging in test cases as if their life depends on this one simple exercise. Well, don't waste too much time on one AP question. You have about 1 or 2 minutes per question on this 40-question test. An hour and 15 minutes for 40 questions. Don't go overboard. Okay, the other ones are all wrong. You can see me after school if you have a question as to why A, B, and C are wrong. Okay, number 3. This is another one where I would recommend that you sort of just test a couple numbers in and see what happens. So they're saying that you have this variable d that's -4.67. And which of these choices, A through E, rounds it to the nearest integer? Well, first of all, you have to know that negative 4.67, when rounded, should be negative 5. If you owe me $4.67, that means you owe me about negative $5. Don't round down to negative 4, because 0.67 is closer to negative 5 on the number line than it is to negative 4. Negative 4.67 would be about there. That's closer to negative 5. That's a further distance. So negative 4.67 should round to negative 5. And they gave you these other test cases. So simply plug in all these test cases in for the D in each of these variations. Yeah, that's a lot of testing. But as long as you can subtract negatives or subtract from negatives, as long as you know what ABS means, as long as you know what it means to typecast with the use of int in parentheses here, and that random, that would be stupid. That's a wrong answer. Why would random numbers have anything to do with this? So the rest of these are fairly, that's one stupid also. A is also pretty easy to roll out. C, D, and E are all variations that might be close to working. Some people, again, will have intuition to figure this out with minimal testing. Other people will need to test all these and hopefully, follow the order of operations correctly. The answer ends up being C, I believe. Does anybody in this room agree? Did anybody do this? Okay, good. I think I don't have my answer key handy, but I'm pretty sure it's C. Let's plug one number in just to see. Let's plug in negative 2.487 here for D. So if we have negative 2.487 minus 0.5, well, that means plus negative. So I add negative 5 to that, and I get 0.987, negative 2.987. But then if I int it, if I typecast it to an int, well, that would chop off the 0.987 and leave me with just negative 2. Is negative 2 what we were supposed to get here? Bingo, it is. That's one checked. I'll leave it up to you as an exercise to plug in these other numbers in here for D to verify that C is the correct answer there.